And welcome. On today's video, I'd like us to talk about complex numbers. I'm not really interested in solving equations or stuff like that. What I want us to do is to convert this rectangular form that is given by z equals to a plus ib to what you call a polar form. So this, remember, that is called a rectangular form. Okay, so this is the rectangular form. So I want to transform this rectangular form to polar form. So I'll show you guys a way that you can convert that without you having to cram the formula and stuff like that. So now we know that A here represent our real part. So our B is what we call our imaginary part. Okay, so let me just use a capital letter I for imaginary part. So if we try to plot that on the Cartesian plane, we have our real part as our x-axis. So on our x-axis we have the real part, and on our y-axis we have our imaginary part, just like that. Okay, so since our real part is A, let's suppose A is somewhere there and B is somewhere here. So where these two meet is there, then we can construct a line from the origin to that point. Okay, then construct the right angle triangle, just like that. So we have our angle theta right there. So notice something about theta. Theta is measured anti-clockwise. Okay, so it's going to be from the real axis like that until it touches the hypotenuse, and our hypotenuse, let's denote it by r. Okay, so now I would like to find the relationship between theta and A, and also the relationship between theta and B. So I'm just going to use SOHCAHTOA. That will be a simpler way to find the relationship. So we know that cos of theta equals A over R. Okay, we know that R is our hypotenuse. Then if I'm trying to make A the subject, I'm going to end up having A is equals to R cos of theta, just like that. And I can also find the relationship between B and the angle. So I can say that sine theta equals B over R. Okay, so if I cross multiply, I end up having B equals R sine of theta, just like that. Okay, so now I go to this equation where there is A I sub R cos theta and where there is B I sub R sine theta. Okay, so yeah, I get Z equals R cos theta plus I R sine of theta. Okay, then we see that there is something that is common, which is R in both cases. Then Z will therefore be R into cos theta plus I sine theta. So now when it is in this form, that is what they call a polar form. This is a polar form. Okay, so if it is in a polar form like this, then we can work on finding other things like what is the modulus of z. There's something that is called the modulus. So the modulus of z is basically r, and from this right angle triangle we see that we can say that it's denoted by a square plus b square using Pythagoras of theorem. Okay, so how about the angle theta? How are we going to find that? Okay, the angle theta, we can simply say that we have tan of theta is b over a. Then if we take the trig function to that side, we're going to end up with theta is equals to tan of b over a. Notice that this will not always be your angle theta. Sometimes it will give you a reference angle. Okay, depending on where you are in the Cartesian plane. If you're in the first quadrant, yes, that might be the case. But if you're in the second, there has to be some manipulation that you have to make in order for you to find your theta. So when we are doing examples, you're going to see what I meant by that. Okay, so let's do our first example. Let's suppose you have z equals 3 plus 3i, just like that. Okay, so in this case, it implies a is 3 and also b is 3. So before I even dive into transforming this to a polar coordinate, what I'll first do is to construct a right angle triangle. Where is this? This 3 is positive, is in the first quadrant, and also that one is positive. So I'm basically in the first quadrant where this is my imaginary and this is my real. Okay, so I can construct my right angle triangle like that, and we agree that theta is measured anti-clockwise, so that is going to be theta right there. Okay, then here I have r. Okay, so using Pythagoras theorem, I'll find that r is equals to 3 square plus 3 square. So this simplifies to 3 square is 9, so 9 plus 9, 18, root of 18. Then I'll get 3 root 2, just like that, isn't it? Then now I have found r, and I can go find theta. Remember, we're converting this rectangular to polar form, and the equation of a polar form is r cos theta plus I sine theta. We have found r, now we want theta. Okay, so theta, using this equation, we see that since we're in the first quadrant, there's nothing that is going to be affected there. Okay, so theta is going to be 3 all over 3. B is 3 and also A is 3. Okay, so 3 over 3 is 1. So basically we're looking for arctan of 1, and we know that arctan of 1 is pi over 4. That is pi over 4. Then therefore we can say z, okay, I'll need some space, let me write it here. Therefore z is, what is our r? Our r, we found it as 3 root 2 into cos of pi over 4 plus I sine of pi over 4, just like that. So this is your answer. You have converted this rectangular form to the polar form. This is the polar form. Okay, so let's look at another example where now our theta is not going to be that easy to find. We have to do some things in order for us to find it. Okay, so I'll just use the same example where I'm just changing the sign. So we had z equals 3 plus something like that. So now I'm just going to have minus 3 plus 3i. Okay, so if I have z equals to minus 3 plus 3i, I have changed the quadrant. What I mean by that is that now on our real axis, remember this is our real and this is our imaginary. Okay, on our real axis I have minus 3, so minus 3 is there, and now on our imaginary I still have 3. So I've changed to the second quadrant. They can meet somewhere there. Then I'll construct a line from the origin like that. Then I can form my right angle triangle. Then since theta is measured anti-clockwise, then you see that theta is actually this whole angle here. Okay, so yeah, you will see that the angle that we're gonna get when we're using arctan is not gonna be this big angle here. Okay, it's going to simply be what is going to be inside of there, and then we're going to call that our reference angle. So let's work on this problem. R is still going to be the same, so is root of minus 3 square plus 3 square. Then r is still going to be 3 root 2. Then I'm actually interested in theta for this problem. Okay, so theta is going to be arctan of minus 3 over 3. Now b is positive, the one that is negative is a, so it's 3 over minus 3. Okay, so here I'm gonna get arctan of minus 1. So arctan of minus 1 is minus pi over 4. Okay, so if that is minus pi over 4, I'm gonna take that as our reference angle. Okay, so this is actually not my theta, this is the reference angle. Okay, so I can say, okay, my reference angle, if I'm ignoring this negative inside there and take arctan of 1, is basically going to be pi over 4. Okay, then now my theta is going to be how far are we from here to there. Remember, this reference angle is actually the angle there. So theta plus this angle, they are equal to 180 degrees. Okay, so they're equal to pi. So if I say pi minus pi over 4, then I'm gonna get the correct theta there. Okay, so theta is basically going to be 4 pi minus pi, everything divided by 4, then this simplifies to 3 pi over 4, just like that. Okay, so this is what I meant to say, that this formula will not always give you the correct theta. It will sometimes give you a reference angle, like in this case, since you know that your theta is measured from the real axis anti-clockwise like that, then you'll realize that, okay, this big angle here is theta, then what you're gonna get here is your reference angle. Then depending on where your right angle triangle is, then you can say, okay, since in this case it is it's making a supplement angle with this one, we can say pi minus pi over 4. Okay, then that is basically what I wanted to emphasize. So we can write our z now in polar form. Say we have 3 root 2 cos of, what is our theta is 3 pi over 4 plus I sine of 3 pi over 4. Okay, so for those of you who didn't follow on this one, let us do another example, and hope this time you guys will pay attention, and feel free to rewind the video so that you can catch up with us. Okay, now let's suppose you have another one where they say z is 1 minus root 3 like that. Okay, so like I said, the first thing that you like to do before you even try to tackle the problem is to draw your Cartesian plane. So we see that on our real axis, we are in the first quadrant. We have 1 there. Okay, this is the real and this is the imaginary. So in the imaginary, we are in the negatives. That means we are here. Okay, so here, suppose you have minus root of 3. So these two, they meet somewhere there. Then you construct the line like that from the origin. Then you can form your right angle triangle. Here you have a 1. Okay, then your theta, since it's measured anti-clockwise, is going to be this whole big angle here. So this is your theta. Okay, so that is how you will know whether the angle that you're getting is correct or not, unless if they stated otherwise. Okay, then now let's get into solving this problem quickly. So we see that r is going to be root of a is 1 square, then plus minus root 3 all square, just like that. Okay, then the r is equal to this will just give us what it will just give us 3, then 3 plus 1 is 4, then root of 4, then we're gonna get r is 2. Okay, then let's go find theta. We see that what we are going to find here is actually not theta but the reference angle. Okay, so I can just say the reference angle is arctan of what is b, so it's minus root 3 over 1, but I'm going to ignore this negative and find out what is arctan of what you call root 3. Arctan of root 3, that is pi over 3. Okay, so if you guys are still skeptical on how to find the angles, you can just go and check Learn with MJ. He uploaded a video where he was simplifying all these things. Okay, so how he basically does the thing is that he just draw the first quadrant like this, then he draws lines, then he puts 1 2 0 1 2 3 and 4, but then he takes square roots of those things. So here I'm gonna have 2, then root of 3, then root of 2, root of 1 will still be 1, and 0 like that. Then those numbers he wrote going down, he's gonna write them again going up. Okay, so I'll just quickly show you guys that. So make sure you know this, or otherwise you can use special triangles. It will still give you the correct answers. Okay, then now you put 0, then 1, then 2. Since we are taking square roots, then you're gonna have root 2, then 3 here, and since we are taking square roots, you're gonna have root 3, then 4 there, then square root of 4 is 2. Okay, so this is basically what you have to go in there knowing if you are having problems in finding your angles. Okay, then yeah, from here what you have is pi over 6, then here you have pi over 4, then here you have pi over 3, and the other one is pi over 2. That is the whole thing is 90. Okay, so how you are going to use this to find your angles is that you have to know that your hypotenuse r is going to always be 2. Okay, so now the thing that we have here is root 3 and 1. Okay, so if we have root 3 and 1, remember it's arctan of b over a, where b is our y. Okay, so b is y and a is x. So basically we have arctan of y over x. So you go look where your y is root 3 and your x is 1. Okay, so you're going to look for a point 1 and root 3, just like that. So where is that? 1 and root 3 is this one. So you come here, say okay, this one, then it goes with this angle. So if you construct the right angle triangle, you're gonna have pi over 3 there, isn't it? Then if you have pi over 3 there, then you're gonna have 1 here and root 3 here. Then we said the hypotenuse is always going to be 2. So if you try to find tan of pi over 3, tan is opposite over adjacent. So tan theta, okay, not theta, but let's say tan of pi over 3 is equal to root 3 over 1. Okay, so if we take tan that side, is going to become pi over 3 is arctan of root 3 over 1. Okay, so this is how I found out that arctan of root 3 over 1 is basically pi over 3. So that's why I have my reference angle as pi over 3. So for those of you who want to understand this, feel free to check out that video I referred you guys to. Okay, so now let's continue. We found our reference angle as pi over 3. Since we ignore that negative, now we have to find our angle theta. So what is going to be our angle theta? Since we are in the fourth quadrant, we see that this is actually the angle that we are finding there. So 2 pi, our theta is going to be 2 pi minus pi over 3. Okay, so theta is going to be what? 6 pi minus pi over 3. Then this is basically 5 pi over 3. So this is your angle theta. Okay, so guys, get into the idea of how you find your angle, otherwise your solution is gonna be wrong. Okay, so now we can therefore say, okay, our polar form is, we have rs2 into cos of our angle is 5 pi over 3 plus I sine of 5 pi over 3. Just like that, you have answered this question. You have converted this rectangular form to the polar form. Okay, so stick around where we are going to be explaining on the next video how to find roots of complex numbers and how to find powers of complex numbers. Thank you very much for watching, and I hope you find this video helpful.